All right. So, like I said, we are going to be looking at adding, subtracting, and multiplying polynomials. I'm going to do like one example of each, but I have a few little details I want to talk about too within that context as well. So, because there's other little topics that I want to make sure we're okay with too. Okay. So, here we go. Question. All right. So first of all, let's talk about a polynomial, right? Okay. So. It is a sum or difference of monomials. Okay. Sometimes the monomials are also referred to as terms. Okay. And a monomial, okay, is a number, a variable, or a product of numbers and variables. Okay. So polynomial is just a sum of a bunch of numbers or variables or numbers and variables that are multiplied together. That makes a polynomial. Right? This is stuff you guys have probably heard before, but maybe not in like official kind of like language, maybe. Okay, you just kind of have this like vague idea about what it means. Okay. So then we have this idea about degree as well. Okay, and it's not the same kind. I mean, it's spelled the same way, but it's not the same degree as what you're talking about when you're measuring an angle, right? It has a different meaning to it here. Okay, the degree of a monomial is the sum of the exponents of the variables. Okay, sum of the exponent of the variables. And then there's the degree of a polynomial. Okay. And the degree of a polynomial is just it's the degree of the monomial term with the greatest degree. I feel like there's like too many degrees in that, but that's exactly what it is. Okay.
Michael, why did you do that?
Okay. So it's darn hydro flasks. It's okay.
Fake one.
Oh, it's a fake one?
Yeah.
Water. Hydro bottle.
Yeah.
So that's some of the anatomy of a polynomial, what makes the polynomial and stuff like that too. Okay, so is it a monomial? All right. Act to the third. Is it a monomial? Is it a number? No. It's a variable? Yes, but it's really like a product of variables, right? Because it's x to the third there. So yes, this is a monomial, okay? It's a variable to an exponent there, so yes. Okay? How about this? Y plus 3y squared minus 5y cubed plus 10. Monomial? No. Okay? It would instead be a polynomial. Okay? Individually, y, yes, is a monomial. 3y squared, yes, is a monomial. Negative 5y cubed, yes, is a monomial. 10, yes, is a monomial. But all together, right, they're being added or subtracted here. That makes it no longer monomial, though, because you're adding a bunch of things together. So no. Okay. And then number 3 here. A squared bc to the 12th. Monomial, yes or no?
Yes.
Yes, it's a product of variables, right? Again, a squared is 2 a's times each other, right? B and then c times itself 12 times, right? So yes. Okay. Although all of these, though, we can identify the degree. Actually, let me do one more here. Last one. 76. Is it a number, a variable, or a product of numbers and variables? Yeah, it's 76, right? It's a number, so yes. Okay. All right, let's talk about degrees then. Okay. What would the degree of this monomial be? 3, right? The highest power there is 3. There we go. So 3. Okay. How about this one? 3 as well, right? Okay, it's not whatever's in front, right? That degree would be 1. It's the highest degree. So 3 is the biggest one we see, so this one is also 3. Okay. This is a polynomial too, right? So we wouldn't combine these, right? You don't do like 3 plus 2 plus 1. Okay. You look at the individual monomials and you see which one has the highest degree. Okay, so then 3 is the answer, right? So this has degree 1. This has degree 2. This has degree 3. This has degree...
1, 0, 1.
Which one is it? 0 or 1. It is one of those. We already have a degree 1 right here. Would it make sense to also call this degree 1?
Yeah.
This has a y. Does this have a y? No. The degree is 0. It's a 0 degree. Okay. You could put a variable in here, right? It could be 10 times y to the 0th power, because y to the 0th is what value? 1. So 1 times 10 there, which is still 10. So if you put a y to the 1th, you now change the value of that. Y to the 1th, y to the 1st. Okay. All right. Well, what about the degree of this?
12.
Degree of a polynomial is the degree of the monomial term with, degree of a monomial. The sum of the exponents of the variables. Close. It's not 14. What's the exponent for this b?
1.
A 1. So what's the degree here? 15. Yeah, be careful there, right? Again, little subtleties, right? Little things we got to pay attention to there, like catch ourselves on that, like, whoops, be careful. Last one, 76. What's the degree of this? 0, right? Again, you like y to the 0 or x to the 0 there, whatever variable you like, kind of thing. Could be 0. Okay. All right, yeah, question. Say again, sorry? But not in 2? Great question, okay? So, this here, number 2, it's a polynomial. So it's got several monomials here, okay? The way we describe the degree of a polynomial is you look at the individual terms. So this one, this one, this one, and this one. And then you pick the highest degree from each one of these 4 that are here, okay? So you agree the degree of this is 1, the degree of this is 2, the degree of this is 3, the degree of this is 0, right? You're okay with that? So then we just pick whichever one's highest, so that's this one, so the degree of the overall polynomial is 3. Here, Slayman, we are multiplying these things together. So this is all one monomial. a squared times b to the 1 times c to the 12. And so you have to add all the exponents together to get the actual degree of that, which is 15. Does that make sense? The difference there? You're adding these, so that separates them, treats them as separate entities. Here it's all one product, so it's treated as one thing, so you have to add all those exponents together. Okay? Is that clear? So that's the difference. That's the difference. All right, a few other things here. We also have this thing called standard form. Okay, so standard form, again, we've talked about this before. This is the same idea as what we talked about with quadratics. Same idea we talked about with cubics. Okay, it's a polynomial written from highest degree to least or lowest degree, if you like. Okay, so it's like basically putting the polynomial in order from highest degree to lowest degree. Okay, we only have one polynomial here. Is this polynomial here in standard form? So yeah, it's not, right? So let me rewrite it here. Okay, so arrow. Okay. Jonathan, what is the highest degree term here? What should we lead with in this polynomial here?
The y, 3y.
Yeah, y to the third. 3y, y to the third there. So we have minus 5y cubed, we'll put in front. Okay, we're just rearranging the terms basically here, okay? What's going to go next there? Let's go to Megan F. What do you say, Megan? What goes next after the negative 5y cubed from here?
The 3y squared.
Yeah, the plus 3y squared. Again, we're just rearranging the terms here. Okay, next would be what, Jack?
Y.
Yeah, the y, right? Plus y, and then that leaves the 10. Okay, and so this is now in standard form. Okay, like that. Standard form.
Should I go to the bathroom?
Yeah, sure. Okay. Okay. So let's actually add or subtract. And what is this really? It is literally combining like terms. Okay? But again, students find some difficulty here. So we'll do two examples here. All right, 4x squared minus x to the third plus 2 plus 5x to the fourth. And we'll add negative x plus 6x squared plus 3x to the fourth. Okay, so we're adding. Adding. Okay. Adding. All right, so let's go to Evelyn. Do we have, actually, what I recommend you guys do is start with the highest degree term, right? So let's start with the highest degree term here, and that is the 5x to the fourth. Is there anything like with the 5x to the fourth here, Evelyn? Yes, so when we add those together, what will we end up with? 8x to the fourth, right? The exponents do not change, okay? If I have 5 oranges and I add 3 oranges, I do not have 8 oranges squared. If I have 5x to the fourths and I add 3x to the fourths, I have 8x to the fourths. The exponents don't change. They change when you multiply. We're adding them. Okay? So done, done. Okay? Thank you. Evelyn, what is the next highest exponent? Let's go to Maya. What's the next highest exponent we have here?
Negative x to the third.
Yeah, negative x to the third. Is there anything like with that negative x to the third there? No. So we'll just have to bring that one down, minus x to the third there, and we took care of that. Okay, thank you, Maya. All right, next. Kaylee, what's the next highest exponent after the x to the third here?
4x squared and 6x.
Perfect. Yes, they both go together, right? That'll make, what's 4 plus 6? 10x squared. Sorry, I put you on the spot there, Kaylee. Right, you weren't expecting that. 10x squared, okay? Add them together. All right. Next, let's go to Aiden. Aiden, what's the next highest degree? We have x squared. What's the next highest power we see here?
X.
Yeah, negative x, okay? Is there anything like with the negative x?
Huh?
Is there anything like with that we can combine up here?
The 2.
Is the 2...
Oh, okay, not really.
Yeah, exactly. So just minus x, and then the plus 2 is left over, so we're all done there. And there's our final answer. In standard form, even. Okay, so there it is. Okay. Questions on any of that? Okay. Keep in mind, I would expect you guys to be able to do this without a calculator, right? So make sure you can add these things together. Okay. All right, let's do a subtraction problem. 12x to the third plus 5x minus 8x squared plus 19 minus 6x squared minus 9x plus 3 minus 18x cubed. All right. I would discourage you from actually doing subtraction here. I would discourage you from doing that. Please don't do that. Okay? I mean, if you feel confident enough to do it and you make it right every time or pretty close every time, hey, do it then, right? But if you don't want to, have to worry about all the different signs and stuff like that, change the subtraction, right? Change that to addition. When you have a minus sign in front of parentheses, just distribute the subtraction, right? So this becomes a plus. Make this a negative 6x cubed, a positive 9x, a negative 3, a positive 18x cubed. And go ahead, take like a minute, put those together. Okay, I'll give you guys this one to try on your own. Go ahead and combine like terms and put it in standard form too, please. Put it in standard form. All right, and I will do the same.
Very important. I guess as long as you're getting these right, just make sure you recognize it all the time. You have like down. That's negative 8. That's negative 6. Negative.
That's not good. That's not good.
Everything else is right. Good.
How much time is that? Use all of it? Oh.
I do. I mean, sure. Like the circle one. I'll do the package. Okay.
All right. Looking good. Looking good. Okay. There is our answer. Questions on any of that? All good? All right, then let's take a look at multiplication, right? That's addition, subtraction. So pretty straightforward, I think.
And again, I don't have too much to show you here, except we'll just multiply some stuff out. We already did one from the warm up though, so okay. I'll just okay. So each term in the first polynomial must multiply with each term in the second polynomial. If you are multiplying more than one polynomial together, you're like 3 polynomials you're multiplying together, do 2 at a time, right? Do the first 2, get that answer, take your answer, and multiply with the third one. I am running low on time here, so I'm just going to jump into one here. Okay, so x plus 2, this is a polynomial, right? 2 terms, x and 2. So these 2 things will multiply here with these 3 things. Okay, 2-term polynomial, binomial, right? Bicycle, 2 wheels, right? 3-term polynomial, trinomial, right? Tricycle, 3 wheels. Okay, 4-term polynomial, 4 wheels, car. That doesn't work anymore. So anyway, we multiply. X times the 1, x times the minus 4x, x times 2x squared. 2 times the 1, 2 times the minus 4x, 2 times the 2x squared. Okay, x times 1, easy, x. X times negative 4x. Now we are multiplying, right? So the number in front of the x is a 1, times negative 4 is negative 4, and the x times x is x squared. So we get minus 4x squared. Okay, because we're multiplying, the variables change. X times 2x squared, 2x to the third. Okay, and now we'll do all the 2's. So 2 times 1 is 2, 2 times minus 4x is minus 8x, 2 times 2x squared is 4x squared. At this point, are we finished?
No.
Yeah, not really, right? I mean, we should really simplify this. This way we've done a multiplication though. You're right. So I guess technically you could say you did what I was asking you to do. But we should really be able to simplify this and combine like terms, just like we did. So the 2x to the third goes in front, minus 4x squared and plus 4x squared cancels out. Negative 8x and x makes a minus 7x, because it's a 1 and a negative 8. And then we have the plus 2 at the very end there. And there's your simplified answer. Okay. All right. I will post the assignment to Schoology because I think we're going to run out of time here. So just check Schoology.